Hi, in this video, I'll be going through the H2 Mathematics 2020 paper 2, and in this question 8, it is a combinatorics question mixed with a bit of probability. And so a computer randomly chooses 12 shapes from 11 circles and 17 rectangles. We're guessing that these circles and rectangles are different, and the number of rectangles chosen is r. Show that the probability r equals to 1 is less than r equals to 2. So you just need to find the probability r equals to 1, which means you get one rectangle. So you just take out of this 17, you choose one. Then the circles you must choose everything else, because you must choose 12 shapes in total. Then you just divide by 28, choose 12, which is the total number of ways to choose without restrictions. And then you find the probability r equals to 2, so it's 17, choose 2 now, times 11, choose 10, over 28, choose 12. Quick comparison shows what we want to see. And for the next part, they say that the number of rectangles now increase to r, and your computer randomly chooses 12 shapes from the 11 circles and 17 plus r rectangles. The probability that 4 rectangles are chosen is now 15 times the probability that 3 rectangles are chosen. Find the value of r. So in this case, the probability r equals to 4 equals to 17 plus r over choose 4 times 11 choose 8 over 28 plus r choose 12. And if you just find the probability r equals to 3, it will be this. Since we know that this is 15 times more than the probability of this, with a quick equation we should be able to simplify, and we solve that r equals to 6. So I hope up to here is clear, and if you need me to answer any of your queries, just leave it in the comments. We'll move on now, since this is fairly straightforward. So for question 9, it says that a factory produces ballpoint pens, and on average 6% of them are faulty. The pens are packed in boxes for sale, and it should be assumed that the number of faulty pens follows a binomial distribution. So then, the quality control purposes, 10 pens are chosen at random for each sample. If 2 or fewer pens are found faulty, then it is accepted, otherwise it's rejected. So now we have to explain what it means by a random sample in this context. So obviously, based on practice, we know the definition, which we always state to be this. To be the random sample means that every pen has an equal chance and independent chance of being chosen. And to find the probability that a randomly chosen box of 10 is accepted for sale, we just let x be the random variable denoting the faulty pen. So x followed by binomial 10, and then the probability of 10 is faulty is 0.06. So probability x less than 2 or equals to 2 is this, and you use the GCE to calculate. And one morning, 75 boxes are tested this way. Find the probability that more than 5% of these are rejected. So the probability of rejection is 1 minus 0.981, so it's 0.01884. And we want to find the probability that the number of boxes rejected. We just need to use another binomial. Now it's 75 bracket 0.01184. And we can calculate 5% more, so y now more than 5% of times 75, so y is actually larger or equals to 4, so it's just 1 minus y less than or equals to 3, which we can use the GC to calculate this probability and use 1 minus that to get this answer, 0.05353SF. So these are very straightforward questions now that just require you to press your GC to solve it. And so the next part will need a bit more intricacy, and we give you an entire alternate testing procedure now. And basically the idea is that, okay, so if we have no faulty pens, then of course it's accepted. If we have 1 or more, then we have to do another test. If we have 3 or more, then it's definitely rejected. So we look at the 1 or more case. In 1 or more case, we need to do the test if 2 or fewer now is accepted, and otherwise is rejected. So for the probability distribution, and we let it denote the number of faulty pens. For the probability of acceptance, now it's either your p equals to x equals to 0, or your x is 1 and the other box has also only 1 or less than or equals to 1 basically. And if you are 2, then your x must equal to 0, and that's the only case, because when you combine it, it must still be accepted. So in that case, you use the GC and you can compute the probability to be 0.893. And for the last part, they ask you to explain why it is preferred to use this alternate testing procedure. And the reason is now you only need to test in smaller sample size, which is 5. So the total time to test in 5 pens compared to 10 is less. So it becomes more efficient, your testing process. As for the last question in this paper, it is a hypo-testing question, and carbon steel is made by adding carbon to iron. This makes the iron stronger and less flexible. So a manufacturing company aims to manufacture bars with carbon by weight is 1.5%. It is known that the percentage of carbon in the steel bars is distributed normally with standard deviation 0.09. After comments from customer, he wants to now test whether it's in fact 1.5%, and he examines 15 bars to determine the percentage of carbon in each bar. But we already know it's distributed normally, and 15 is small, but it doesn't matter because it's distributed normally. So we will find the critical region. So we know x is normal mu, 0.09 squared. H0 is just mu equal to 1.5, and H1 is just mu not equal to 1.5, since you want to test whether it is 1.5 or not. So it can be less than or more than. Now under H0, we just have our test statistic, which is Z, which is x bar minus mu over sigma over square root n, which then we know follow normal 0.0 and 1. So when we now know Z is this answer. So in that case, to find the critical region, it must be either Z is in here or in here, which is the 0.025%, because it's 0.05 when these two added up. So when you split them evenly, it's 0.025 on the right and 0.025 on the left. So it's either you're less than or equal to minus 1.96, or you're more than or equal to 1.96. And by a good algebra manipulation, you're able to find that the x being a percentile being trapped within 0 or 100 means it's 0 to 1.45 or is 1.55 to 100. Okay, so next part, it gives you a new type of bar, and in this mild steel, the amount of carbon is 0.25% only. So he likes to declare a hypo testing on the random sample of 40. In this case, explain why he takes 40 when he only took 15 for the other one. Well, because now in the previous case, you already know it's normally distributed. So but in this case now, for the flat bars, the distribution is unknown. So because of that, when we want to do the hypo testing, we will need the help of CL, central limit theorem, and hence we need a large enough sample size, which is more than 30. So 40 is sufficient. And we want to find the amount of carbon in a random sample of 40 with these statistics. So calculate the unbiased estimate. So we just need to find x bar and s squared. So x bar is just using this formula, sum of x over n. S squared is this formula, 1 over n times square sum of x squared minus x sum of x whole thing squared over n. And this will be the answers respectively. So this shouldn't be too hard. Just press calculators and you should be able to get the answer. And now we need to just do another test now with the central limit theorem, which is essentially the same, but now it's one tail because they ask for more than. So you just use the central limit theorem, you can find the test statistic, model with a normal approximately, and Z will just be this value now, which is 2.0937. And by GCE, we can show we just compute the p-value because we don't even find the critical region in this case. So we just calculate the p-value and see that it's less than 0.025, which means we can reject H0. And thus conclude that the mean amount of carbon in each flat bar is more than 0.025. So that's all for this series. I hope you've enjoyed it. If you have any question, leave it down in the comment section down below. Like, share and subscribe, as it will do our channel a big favor, as we reach out to more people to learn more about H2 math in general, or math in general. When they want to practice anything, they can just look for the questions. I'll see you again and have a nice day. Bye.